Last chapter, chapter 8. That's going to be on the final. So let's go through these. Let's at least try to get half of this done. I think we should be able to get at least half of it done. We'll see. Find the geometric mean. Now, some of you guys really struggled with this stuff on this test. And some of the simple stuff, and I can just tell, I just know for a fact that there's no way you could have been paying attention in class or studied this or anything and not get these right. It's just impossible. It really is. So let's do it now. If you didn't pay attention before, let's pay attention now so that when you take the final, you'll be able to figure out. It's 5% of your whole entire grade for the year. Okay, so it's not a huge chunk, but it's a pretty decent. It's definitely worth a lot more than just a regular test. All right, for the whole entire year. So it says find the geometric mean. The geometric mean is a proportion. Let me get a little straighter line. It's a proportion, and the geometric mean it's a variable. You're trying to find it. We'll call it x. You can call it any letter that you want. But where do we put the geometric mean? We set up a proportion, two fractions equal to each other. We put 1x up here and then 1x down here. Everybody with me on that? Okay, if you don't do that on the test, you just haven't paid attention. There's just no way in the world anybody could sit here and watch what I'm doing and really try to concentrate and not be able to do this on the test. So the geometric mean goes here and here. That's what you're solving for. Well, what goes here and here? 2 and 8. So you don't just go 8 times 2 because you have to cross multiply. What's x times x? It's x squared. Now, what's 8 times 2 or 2 times 8? It's 16. So your answer is not 16. X squared is equal to 16. Okay? Well, 8 times... Right. But don't try to memorize like a shortcut. Set it up like this, okay? Set it up because you're going to be doing this. For this whole problem right here, you're going to be doing geometric mean. Okay, don't just say, okay, I just multiply them and take the square root. Yeah, it's exactly what you're going to do, but you need to know how to set this thing up because it's really going to help when you do this stuff down here. So don't try to do shortcuts. Just set it up like this. So x squared is 16, and so what do you have to do? Take the square root of both sides. What's the square root of 16? It's just 4, so you just write your answer like that. Easy as that. Everybody with me on that? If it doesn't come out to an even number, you just keep it under the square root. If this came out to the square root of, like if this was a 5, this would be the square root of 10, right? You just keep it square root of 10. Don't turn it into a decimal, just keep it square root of 10. But this one does come out to a nice whole number, so write it as a nice whole number. Okay, what about this one? 9 and 36. Again, it says find the geometric mean. So we do this. You should do this every single time you find the geometric mean. You should set up two fractions equal to each other. The geometric mean goes here and here. And again, you could call it any letter that you want. I call it x. And then the two numbers go in those other two spots. So you got a 9 and a 36. And you cross multiply. So x squared, let's make that look like a squared. X squared is 9 times 36. Now there's a way to simplify this. I told you could just write it as one big square root, so let's just do it like that. So it's 9 times 36. That's 324. And I'm perfectly fine if you just multiply it together, take the square root, so x is the square root of 324. But let's just do a little extra step. Let's just see if this comes out even. Let's take the square root of that. So the square root, oops, did the wrong button. The square root of, let's see, second function answer. There we go. Yeah, that one actually does come out even. All right, so give it a shot. Put it in your calculator and give it a shot. Now, if you would have written the square root of 324, I would have given that to you. If you would have just wrote the square root of 16, I would have given that to you. I wouldn't mark it wrong. All right, but it's so much nicer to make it into a whole number if it does come out to a whole number. All right, they all don't come out to whole numbers, but sometimes they do, and you should write it like that if possible. All right. Now look, if you can't do geometric mean on number 1 and 2, there's no way you're going to get 3, 4, and 5. There's just really no way. So you've got to know how to do geometric mean with 3, 4, and 5. Let's get rid of all that. Writing. All right. Start with a clean slate here. Let's go a different color now. Let's go with this red. Oops. All right. Now, this is set up as basic and simple as I could possibly set it up for you. Okay, I could have made it a lot more complicated. I really could have. But I made it just straightforward, super, super basic. These three variables right here, x, y, and z, they're all geometric means. X is a geometric mean, so is y, and so is z. All right, so let's do z first. We don't have to go in order, do we? Let's do z first. Z is a geometric mean. So if I said that g is a geometric mean, we set up our two fractions. If z is the geometric mean, where do I put it? I put the z here, and I put the z right here. Between what two numbers? Now look at number 1 and 2. They told you which two numbers on 1 and 2, didn't they? On this one, you have to figure out between which two numbers. Somebody tell me. Z is a geometric mean between what and what? Between 3 and 9. And you have to know that. All right? I saw people that just left this completely blank. There is no excuse for that. It's just because you didn't study it. You've got to study this stuff. Some of you guys, this is your last shot, okay, at bringing it up to whatever grade, okay, whether it's passing or getting a D or, getting a C or a B or an A. This might be your last chance. So let's not say school's almost over. I mean, look, I feel the same way you do, okay? Last full day, I'm just as excited about it as you are. Believe me, I might be more excited about it than what you guys are. But that doesn't mean we quit and we stop. I'm still teaching hard all the way to the last second that I could teach you guys, all right? So you've got to do the same thing. You've got to work hard until you've finally taken your very last final, and then you can take a break. Then you can take a breath and enjoy your summer. But let's keep working all the way up until your last test is finished. All right, so you got one more weekend to put some studying in. This is it. This coming weekend is it. So let's watch some YouTube videos, look at your notes, look at other videos online, whatever. Okay, whatever is going to help you do this. Get together with somebody else in this class or another class that's taking this stuff, all right, and go over some problems. Make sure you know how to do every single one of these problems. So Z is a geometric mean. Between what and what? Between 3 and 9. Why is that? Well, we talked about it a long time ago. Just remember it. Just memorize. It's between the two segments of this whole big hypotenuse. So if they give you this one and this one, Z is the geometric mean between those two numbers. So I put a 3 and a 9 right there. And now I do exactly what we did on 1 and 2. I just cross multiply. So Z squared equals 9 times 3, which is 27, and Z equals the square root of 27. Just leave it like that. There's no reason to put that into a calculator. There is a way to simplify that. I don't really care that you simplify it in this test anyway. If you have Algebra 2, you probably will have to simplify that. But in here, I'm not going to make you do that. All right? So I'll keep that one up there. So that's what Z is. What about, let's do X. Oops. Let's solve for X. X is also a geometric mean. So what are we going to do? We're going to set up our two fractions. We're going to put X here and here. But we got to know between what two numbers. X, this leg of this big right triangle, is the geometric mean. Between what? Between the whole thing, which is what? 12. All right, because that's 3 and that's 9. The whole entire side, the whole entire hypotenuse is 12. And what? It's the geometric mean between 12 and the side that's what? It's adjacent or closest to that X. All right? So X is geometric mean between the whole hypotenuse and the little segment that's closest to the X. So it's between 12 and 3. So what do I do with that? I put a 12 here and I put a 3 here. And then I just do the same thing as I've been doing. So X squared equals 12 times 3 is 36. Can you take the square root of 36? Yeah, absolutely. It comes out to 6. All right? So you should write it as a whole number. Now, if you wrote the square root of 36, I'd still give you credit for it. But shame on you, okay? Because you should know what the square root of 36 is. All right? Let's see, what else? Got to solve for y, don't we? So let's get y by itself. So y is also a geometric mean. I'll just use some empty space down here. So y is a geometric mean. So I put y here and here. Between what and what? Between the whole thing and the segment that's closest to the y. So it's 9 and 12, right? And you can cross multiply. Y squared, 12 times 9, what's that, 108? Square root both sides. Square root of 108 actually does simplify, but I'm going to let you just keep it square root of 108. Don't put it into a calculator. Don't give me a decimal. Just keep it square root of 108. And those are your three answers right there for x, y, and z. You're all right with that? And on the test, it's not going to be any more difficult. The numbers might be different, okay, but it's not going to be any more difficult than that. And you got to know that, okay? There's really no reason. We did that a lot, and still I had people on the test. It's so frustrating that didn't even attempt to do it. Or you might have attempted, but it was a pretty weak attempt, and it just showed that you just haven't studied and you haven't really tried. I'm not asking for perfection from everybody. I just want you to give some effort, okay? I just want to see that you've given some effort. That's what I want. Now, on a test, though, you do have to get it right to get credit for it, but homeworks and stuff. All right, let's do this. Determine. We kind of did this the other day, didn't we, when we found out if three sides made up a triangle or not? Was it in here or the other class? I remember one of the classes I did that. So on this one, you got to go a step further. It says, first of all, determine whether each set of numbers can be the measures of the side of a triangle. So first of all, we have to determine, can that even be a triangle to begin with? Well, how do we determine if it's a triangle? Add what up? Add the two smaller ones up, right? So 20 and 30 are two smaller ones, so you add them up. What has to be true about that sum? What has to be true about those two numbers that I just added up? It's got to be larger than the largest side. That's right. So if I take the two smaller ones, 20 and 30, it has to add up to be bigger than the third one. Does it in this case? Does 20 and 30? Yeah, 20 and 30 is 50. 50 is bigger than 40, so yes, it's a triangle. But do I stop right there? No. What's the rest of the problem say? So it says determine if it can be a triangle or not. So yes, it's a triangle. So it says if so. Well, we said yes it is, right? So it is. So classify it as acute, obtuse, or right. Now how in the world do I do that? That's where you have to do a little bit more math. Let's scooch this over so I have some room to write. So how do I do that? Remember, I call this my A, B, and C. All right, the two smaller ones are A and B, and the largest one I'll call C. So how do we know if it's acute, obtuse, or right? Well, I got to do what to them? I got to take 40, I got to take the C squared and compare it to the A squared plus B squared. So I take the longest side and I square it, and I take the two smaller ones, I square them, add them up, and then I compare them. What if C squared was greater than A squared plus B squared? What kind of a triangle would it be? It would be what? Obtuse, right. What if it was less than? What if C squared was less than these two? Then it would be acute. What if C squared was actually equal to this? Then it would be a right triangle. That's how you determine what kind of a triangle it is. Now, we don't know what it is right yet, do we? So let's put the stuff in here. 40 squared, the A and the B, it's the 20 and the 30, so we go 20 squared plus 30 squared. Let's see what we get. What's that? Is that 1600? And that's what, 400? And that's 900. So we take 1600, we compare it to this. What's that? 1300, isn't it? What is 1600 compared to 1300? It's greater than. So what kind of a triangle is this then? It's obtuse, okay? If C squared is greater than A squared plus B squared, then it's an obtuse triangle. So I write obtuse. Yes. Yes. So it says justify your answer. That's what it means by justifying your answer. This right here, all that work right there justified my answer of that being obtuse. Now look, on the test, I didn't mark it wrong. If you put obtuse and you didn't justify your answer and you didn't show your work, I gave it to you anyway. All right? I mean, you could have got it all kinds of ways. You could have guessed. You could have looked at somebody else's paper. You could have just whatever. Or you could have known how to do it, right? So I didn't mark off if you didn't justify your answer, but you really should, all right? We good with that? Let's do a couple more. Let's do this. Let's first of all, again, let's first find out if it's a triangle to begin with. So what do? We take the two smaller ones, 6 and 12. We add them up. What do we get? 18. Is 18 bigger than 20? It's not. So do I even go any further steps? It's not even a triangle. So I put no triangle. Some of you guys are putting no triangles for a bunch of them, all right, and not really knowing why you're doing it. I can tell. I mean, I just know when I see what you're writing on the test that you just have no clue and you're just guessing. Okay, you look at this, you're like, well, I got a percentage of a chance to get this right, so I'll just write something down. right? And I know that's what some of you guys are doing, and it doesn't take that long. It really doesn't take that long to actually figure it out. What about this one? This one looks a little crazy, but it's actually kind of easy. Let's do this first of all, the square root of 5 and square root of 12. Now, I have no idea what that is, how to add those up. So I'm going to use a calculator for that. Watch. Square root of 5, square root of 5, and I'm going to add that to the square root of 12, square root of 12. Let's see what I get. I get that number right there, 5.7. Let's compare it to the square root of 13. So the square root of 13. So when I added them up, is that bigger than the biggest side? Yeah, it is. So is it a triangle? Yes, it is. So you always have to determine that first, if it's a triangle to begin with. Okay, now we know it's a triangle. Let's figure out which type of triangle is it. Is it acute, obtuse, or right? So we take the longest side, that would be our C, and we square it. Now watch this. It looks complicated, but it's actually easier than what we did over here. It really is. Because what happens when I square a square root? It's not 13 squared.
It's just 13.
It's just a 13, right? Let's compare it to the square root of 12 squared plus the square root of 5 squared. That's right. This is how easy this is. If I square a square root, it's just a 13. If I square a square root here, that's just a 12, and that's just what? 5. So I've got 13 here, I've got 17 here. What is 13 compared to 17? It's less than. So if it's less than, what kind of a triangle do we have? An acute triangle. It's kind of easy now, isn't it, once you see that? Wouldn't you agree? Yeah, I think so. Of course, I'm the teacher, I know. I always say that, and kids always get mad at me. But you're the teacher. It's supposed to be easy for you. It wasn't always easy for me. Okay? I had to do a lot of work, and I had to figure stuff out. Even when I first started teaching geometry, because my first couple years of teaching, I never taught geometry. And then one year, they asked me to do geometry. I was like, oh my goodness, I haven't had geometry in so long. And I was scared to death. But then after that first year, getting under your belt, and you start learning this stuff. And I had to study. I studied every night, geometry. I studied all those theorems. I studied all that stuff because it's not a lot of stuff that I had in college. I had a lot harder stuff in college, and you tend to forget it if you're away from it for a while. So I had to study it myself. So I went through the same thing you did in high school and when I taught the stuff. Okay, so I've learned it. And that's why I think I can expect you to do the same thing. Now look at this. This says solve for x, round to the nearest tenth. And I'm telling you, some of you guys would just have gotten killed on the test if I would have stuck to my guns and marked it wrong because you didn't round it exactly the way you're supposed to. Some people rounding it 2 decimal places. Some people rounding it to no decimal places. And it says right there in bold, round to the nearest tenth. Okay, follow instructions. What about this? I've got 2 sides of a right triangle. What can I always use if I have 2 sides of a right triangle? Pythagorean theorem. That's right, Pythagorean theorem. All right, and that's what you're going to use. This is not one of those special ones. It's not one of those, what do I call those things? Pythagorean triples. Remember those? Like 3, 4, 5, 5, 12, 13, those kind of things. You just have to do Pythagorean theorem. So let's do that. And we'll do it over here. Remember, this is always the C in Pythagorean theorem. So I've got x squared equals 16 squared plus 33 squared. And let's figure out what this is. If I want to get x by itself, how do I get rid of a square root? Or sorry, how do I get rid of a square? Gave it away. Take the square root. So basically, that's what we're doing on our calculator. So I can do it all in one shot. See what I did? Instead of going 16 squared, writing that number down, and then 33 squared, writing that number down, and then putting into a calculator again to add them, and then you put that into a calculator to take the square root. Instead of doing all that, I'm going to do this in one shot. So watch, it's the square root of 16 squared plus 33 squared. I'd like to close that. See what I did? I'm taking the square root of that whole thing, aren't I? That's exactly what we're doing right here. And there you go, 36 point what? It says rounded nearest tenth. So if I was going to be really picky on this, what should your answer be? 36 point what? 7. Okay? 7. The 7 rounds that 6 up to a 7. So 36.7. 36.7. All right, this is also Pythagorean Theorem. And let's see how we do this. Again, what's our C? That has to be our C. The hypotenuse is always the C. This is what gets people confused sometimes. The hypotenuse has to be the C. This is my A, and this is the B. All right? So I'm going to go 28 squared equals x squared plus 11 squared. Now I have to solve for x. Now this one's a little tougher because I have to do a little bit of algebra and get x by itself. So I'm going to subtract an 11 squared, so that'll go away. So what do I have? I've got 28 squared minus 11 squared equals x squared. Now again, instead of just putting everything in the calculator, instead of going 28 squared, writing it down, instead of going 11 squared and writing it down, and then subtracting it in your calculator again, look what I can do. How can I get x by itself here? Take the square root of both sides. So look, I can just chuck that all in the calculator in one shot, and then I'm done. So let's do that. Square root of 28 squared minus 11 squared, close parentheses there, hit equals, and there we go. What does this round to? 25 point what? 7, right, because you look to the right of it, that's a 4. The 4 does not round the 7 up. Okay, so it just stays 7, 25.7. There it is. So that's a little different. It's still Pythagorean theorem, but we had to get x by itself. Over here, x was already by itself. Do you see that when we set it up? But when x is one of the legs, you have to get it by itself, so you subtract an 11 squared from both sides. And then you stick it all in the calculator, and there you go. Okay? All right, that's all we're going to do today, okay? I said we'll do half of it, and we'll do the I'll do the other half in third period tomorrow. So make sure. Now that's a big chunk of it, okay? 11 through 20, that was the hard stuff. There's that special triangle, 30, 60, 90, 45, 45, 90. Sine, cosine, tangent for all this stuff. And even for number 20, sine, cosine, and tangent. So make sure, if we don't have class tomorrow, or if it's shortened or whatever the deal is, make sure you watch that video from third period, because I will do that tomorrow if everything goes as planned.